welcome back to Couch to Coders. In this module, we're going to introduce GROUPBY and start laying the foundation so that we can start using aggregate functions in our SQL queries. Taking a quick look at our outline, this module is broken up into two parts. Part 1, which you're in right now, is the level of data and GROUPBY. This will take about 13 minutes, and what we'll do is we will introduce what your level of data is. We'll go over a basic GROUPBY example with a toy set, and then I'll show you how the syntax looks like in BigQuery. The second part of this module, we're going to take a slight detour, and we're going to look a little bit more in depth on dates and how to work with dates and timestamps in BigQuery. That video is a little bit longer, it'll take about 18 minutes, but we go through a lot of different examples on how to navigate and move around with the date functions. We've been covering a lot of new keywords recently, so let's just take a minute and review everything we've learned and introduce our new keyword GROUPBY. We have select. Select tells us which columns we're picking, and we think of select as cutting up our data vertically, pulling individual columns. From tells us what data source we're using, where we're getting all of our information from. Where is like a cousin to select. Instead of cutting up your data vertically and pulling columns, you're cutting up your data horizontally and selecting the types of rows that you want. And in the example, when we used where, we looked at it as if it was a filter on a website. Our new keyword that we're going to cover in this module is GROUPBY. GROUPBY aggregates, or, and I put in quotation marks, rolls up the data. And a lot of people in the field, instead of saying, oh, I'm aggregating the data, they say I roll it up. So if you hear either one, those are the same things. What GROUPBY does at a high level is it allows you to use aggregate functions. And aggregate functions might sound like a big word, but if you've ever done Excel using sum, average, or count, that is an aggregate function. And it works the same exact way as it does in SQL. We also have order by. That allows us to sort the data, and we can do it by individual columns in increasing or decreasing order. And then we have limit, and we've been using this since the very beginning of this program, and that allows us to reduce the number of rows that we return with each query. Atomic data. Atomic data, defined simply, is data elements that represent the lowest level of detail. And when we say data elements in terms of SQL, we mean columns. So which data columns represent the lowest level of detail? Okay, that still might not be clear, and you're like, when did we start a science class? What are we doing with atoms? This is crazy. Let's break down this word into its simple parts. So for atomic, we can think of an atom. And if you remember back in your early high school days or elementary, depending where you were, an atom is the lowest, smallest unit of matter. So when we say atomic data, we mean smallest unit. And in Couch to Coders, what I like to call it is the level of data, because atomic data sounds kind of confusing to me and too fancy, and I think the level of the data makes more sense to me. Okay, level of data. Level data is specifically a Couch to Coders term, so if you say it to someone else, they don't know what you mean. You can also say atomic data. They probably still won't know what you mean, but they can at least Google that. Level data, how I would explain it, is a combination of columns that make each row unique. So pro tip is when you're exploring new data, as soon as you identify what level your data is at, go ahead and comment that up at the top of your code, and you're going to reference that whenever you're doing your aggregate functions, and it will save you a lot of time. So here's an example of a little baby toy set, and we have 3 columns: name, species, and color. So if I were to look at this data, and let's assume that we have even more data on this. This is our vet data that we've been working on. Are there any combinations of these columns that I could guarantee would make each row unique, even if someone new came in with a new pet? The answer is probably not, because what I have is fairly generic. I have pet names, species, and color. I know that color is certainly not going to make our individual rows unique because you can have a lot of animals that are orange, a tortoiseshell, or brown. So that's not going to help us. Same thing with species. Most vets probably only care for dogs, cats, and maybe a bird or a reptile here and there. Same thing with name. People are generally not super creative with names, and even if you do have a very unique name, it's not guaranteed that someone else isn't going to come in with the same type of name. So what if I were to combine some of these? And I said, well, color's not unique, but color species is a little bit more unique. And that's true. There are probably definitely a lot more brown pets than there are brown dogs. That being said, the chances of someone coming in with another brown dog, highly likely. That's not something that makes this row unique. And similar, like with the names, like I said before, is that you're not really guaranteed to have any unique names. So even if I were to say Bo is a brown dog, the chances of me getting another brown dog named Bo is not as high as getting a brown pet or a brown dog, but it's still fairly likely. So what could I add to this table that would guarantee that I could have a unique row? What if I added the owner email? Email is a really common way to make a row unique because in order to have a valid email, that particular server, if it's Gmail or Yahoo or AOL, they don't allow duplicate usernames. So they already scrub it and say, if you have this email, you're the only person who has this email address. So now that we've added the owner email, what could I say would guarantee or at a high likelihood ensure that I have a unique row? I would say that it's reasonable to assume that the email and the pet name would make each row unique. There is a possibility that someone has two pets with the same name. It's possible someone has a cat named Kitty and a dog named Kitty also. It's unlikely, but I guess it is theoretically possible. So you could probably put in species, and if someone was really crazy and they had two cats with the same name, then you could go by color. And if they had two cats with the same name and were the same color, I would call them clinically insane. But then you could add an additional column where maybe you create a pet ID. And you say, this pet we call ID 1 and this pet we call ID 2. But for the purpose of this example, we're going to say that it's safe to assume that just with the email address and the name, we can ensure that each row is unique. You might think, why not just the email address? Well, that's because we see these bottom two rows here. We have two pets for the same email address. I think that it's reasonable to assume that many pet owners have more than one pet. So if I were just to say, oh, what's everything with this Gmail associated with, I could have more than one row. So that's why we need the combination of the email address and the name. If this is feeling really confusing and overwhelming, don't worry, we're going to keep going through it. And once you see a few examples, it's going to feel a lot more natural. We're just introducing the topic right now. Okay, so let's use this data where we've added the owner email and let's level it up. Let's aggregate the data. How many pets does each owner have? Okay, so right now our data is at the owner pet name level. We want to aggregate, level up, or roll up the data to just the owner email. So we want to level up the data from the owner/name to just the owner. And what we'll get is this. We have the owner email, and then we have the count, that's our aggregate, of pets. So CD email has one pet, AE email has one pet, but C2C has two pets. And we know that because we see here C2C is listed 2 times. One for Jinx, one for King. So you'll notice that when we aggregate our data, we lost 1 row and 2 columns. Why is that? In general, when you're aggregating data, what it means is that you're going from a zoomed in view and you're zooming out. And as you zoom out, you start to lose some of that visibility into what they call the granularity, or that really low level of detail. So every time you're aggregating, in general, you're going to expect that you're going to lose some of your rows and you're going to lose some of your columns. That's just something to keep in mind. Suppose that I said, well, I don't want to lose that granularity and I want to get the count of pets by the owner, email, name, species, and color. I want to keep it all. What would happen? I would get this. So I'd have the owner email, I'd have the name, the species, the color, and then I would have the count. And so if we know that owner, email, and name is only one pet, then we're always going to have one. The only way that this would show two is if we had that insane person who had a cat named Jinx that was a tortoiseshell and they had two of them somehow. Now that we've looked at a group by from a high level with a toy set, let's look at what the code would look like in BigQuery. So this here is a snip of what group by looks like in the BigQuery console. Let's break it down. First, we have our select. We select the passenger count. We have something called max of total amount. And then we have this as max amount. Okay, so what this means is that we're rolling up to the passenger count level. Okay, this would be the same thing as the owner email in our previous example. We want to find the max or the highest of the total amount. And this as, you're like, what is this? This we're just renaming. And we can call this whatever we want. We could say as M, as max, as maxi, whatever you want. This is just so that we know, okay, we were looking at the total amount before, now we're going to have it at the max, the highest amount. Our from is the same as before. We're only looking at where passenger counts equal to, and then what we group by, this is where we're leveling up the data and we're leveling up to passenger count. And again, if you feel like a little overwhelmed, this is just an introduction. We're going to do a lot of examples, and once we start getting our hands dirty in the data, I think it'll be a lot more clear. So let's review everything we've talked about today. We learned how to identify the level of data. We introduced the group by keyword. We can alias or rename columns by just simply typing as after our aggregate function and renaming it to whatever we want. In our next lesson, we're going to take a quick divergence and we're going to go over a couple of date time functions, and then we'll come back and do even more examples with the group by. See you then. I hope you found this video helpful. If you did, I would be so appreciative if you could like the video and subscribe to help me create more content for you. Thank you.